Yeah, so let's start today's discussion. And to start with, let's talk about the CIF and the evaluation pattern as well. That would be applied for this semester. Right? So, looking at this particular course, the title says Software Architecture and Quality Engineering. Right. So, one thing you might have got an idea that we'll be focusing on your uh, software architecture part, right? Some issues with my pen. Let me work on it. Yeah. So started working now. So you might have got the idea that we our focus in this course will be on the software. Mhm. Let me restart it. Yeah. So our focus primarily will be on your software architecture part, right? And then we'll focus on quality engineering. The initial part is going to be very interesting, where in our unit 1 we'll be dealing with your architecture and then architectural design patterns. Any idea about architectural design patterns? Okay, any idea about design patterns? See, there are two things. One is architectural design pattern, another one is your software design pattern, right? So from the term itself, you might have got some idea that okay, this is like something which is dealing with patterns. Patterns. When we say okay, any idea about patterns? What do you mean by pattern? What do you mean by pattern? No clue. See, I am expecting this to be an interactive class. So, any idea about
Sir,
design pattern?
something that repeats, like we can reuse something.
Yes,
So repetitive or proved designs.
right. Reusability is there, right? Repetitiveness is there, and here we are saying architectural design pattern, right? So, architecture, everyone is aware about. If I'm not wrong, I only covered your basics of software architecture in your software engineering classes. Yes or no?
Yes, sir.
Right. So, any idea about software architecture? I'll definitely throw some light in the beginning on what basically the software architecture is, and we'll talk about your architecture in the life cycle. We'll talk about enterprise level software architecture. We'll talk about solution architecture. We'll deal with a very interesting and very popular 4+1 view architecture. Right, and then we'll talk about the differences and the similarities between your architecture and design. We'll talk about your patterns. We'll also talk about how to document these things, right? And Then this part is something which is very interesting. We'll talk about your broker pattern, MVC pattern, pipes and filters, client server, peer to peer, service oriented, publish and subscribe, share data, your layered pattern, your map reduce, your multi tier uh, architectural pattern. So, right. So, all these things will be covering in our coming classes. But before that, let's talk about architecture. So, basically, when we have a blueprint, right? Just like for a building, we get a blueprint. Similarly, for softwares, we get a blueprint that is called as your architecture. Right. So we'll be giving good amount of time in this portion as well, and then we'll talk about quality. Right. Quality here we are dealing with software quality. So where we'll talk about what basically the software quality is, what are your software quality attributes, what are the specifications, and do we have to pay some cost for this quality, and what basically are defects, faults, and failures. So we'll see that defects are leading to faults, faults are leading to failures. Then what basically your defect rate is, what is your reliability. Then we'll talk about defect prevention, detection, and since we are able to detect it, we'll talk about defect containment as well. We'll look into the software reviews part, and we'll talk about some software quality metrics as well, right? Where we'll have like product quality matrix, defect density matrix. We'll deal with customer problem matrix. So these are some of the matrices, right? Where we'll see some basic formulas associated with each of these uh, matrices. Then we'll talk about, in our fourth unit, we'll deal with the software quality models. So we'll deal with your reliability models. We'll talk about a very interesting Rayleigh model. And then we'll see some exponential distribution, and we'll see the software reliability growth models as well, and the software reliability allocation models as well. Then there will be some criteria for evaluating these models, how to evaluate these models, right? So this we'll be dealing in our unit 4, and then we'll talk about software quality assurance, right? SQA activities. So there we'll talk about quality planning, control, and the improvement processes. And then we'll talk about evaluation of your software quality assurance, some major software quality assurance activities, some major software quality assurance issues. Then we have like zero defect softwares. Then we have software quality assurance techniques. Then we have like statistical quality assurance. We have like total quality management. We have quality standard and processes. Then we have like software verification and validation part. That would be the last portion of this particular course. So verification and validation of the softwares, right? So we'll deal with nature of verification and validation. We'll talk about impracticality of testing all the data and parts. Yeah, proof of correctness, another very interesting problem we'll deal with. So these are some of the books we'll be dealing with. We have this Jeff T and software quality engineering, and then we have like matrix and models and software quality engineering. The second edition we'll be using, and yeah, these are some of the reference books which we'll be referring to. And yeah, so if for the evaluation, what we are going to do is like we'll have two quizzes, and then we'll have two assignments, and obviously one midterm and one end term. Right, weightages will be like 35, let's say, and then 25 for midterm. This thing will comprise of 40, so it will be like for quizzes it can be 15 plus 15, and for assignments it can be 5 plus 5. Now, before freezing it, let me know if you have any views on this kind of distribution. If you have any inputs on this kind of evaluation methods, or if you're fine with it, then we can go ahead with this. I'm ready to accept. I'm ready to take some inputs from your end. So, any inputs from your end?
Sir, it's fine.
Okay, Rahul. Anyone else having any issues with any of the components? Okay, fine, fine. Yeah, so then we'll stick with this. So, yeah, looking at the current scenario where things are not in the normal shape. So normally, I take quizzes in the surprise. I prefer to take surprise quizzes, and in this scenario where things are like on online mode, and I do understand that you have to give a lot amount of screen time on going through these online classes and other stuff. So one thing which I am doing is that I'm not giving any weightage to the attendance part. Plus, all midterm and or end term obviously will be the announced ones, and similarly your quizzes will also be announced well in advance. And for assignment submission also, I'll give uh, decent amount of time for submission. By the way, I have shared some of the videos for refreshing some of the topics, right? So how many of you could go back and look into this? I hope you might have got some videos I have shared on in the Google Classroom. I'll share the CIF part. I'll share the evaluation. Everything I'll share, and for the videos also on these class recordings, I'll prepare a separate playlist, and I'll share that link also. After this class gets over, I'll share the recording part, and from next time onwards, all the recordings will be added to that particular playlist only. Yeah. So any doubts up till now? Any inputs? No. See, if you have anything related to evaluation part, or maybe any input related to teaching, so all your points are welcomed. Fine. So let's go ahead with the discussion. Right. Okay. So it was already. Yeah. Yeah. So you don't have to follow this particular thing, right? We are not going to follow uh, this distribution. We are going to follow the same one which we have discussed just now. Now, the first point is what basically is your software architecture, right? So this software architecture basically refers to the fundamental structure of a software system, because see, we are referring to software. So uh, we are dealing with software architectures, right? Architecture can be for anything, right? It can be for a building architecture, it can be your, let's say, architecture for some woodwork, right? So here we are dealing with your software architecture. So basically we are referring to the fundamental structure of a software system, and the discipline of creating such structures and systems. And each of these structure basically comprises of small software elements, right? And these software elements are in some sense are related to each other. So your architecture of a software system can be is a metaphor, which is something which is analogous to the architecture of a building as well. And this basically works as a blueprint for the system and for the to be developed system as well, because this will be a to be developed application. And this basically is like laying out some necessary tasks which can be executed by your design teams. And the software architecture basically gives you, some fundamental structural choices, that this is how my software is going to be built, this is how my software is going to look, and which when it will be built. So here, the choices can be your structural options and the design. In we can take a call that, okay, whether it will be a cloud-based application, it can be your desktop-based application, and so on and so forth. All right, so let's formally see basically what basically the software architecture is. So the software architecture of a program or computing system is a depiction of the system, right? This is like how my system is going to look like, that aids in the understanding of how the system is going to behave. So your software architecture basically serves as the blueprint, right? We have used, and in fact, we have coined this term several times, that this is nothing but the blueprint, right, for both the system and the project developing it. Defining the work assignments that must be carried out by design and implementation teams as well. The architecture is the primary carrier of system qualities such as your performance, your modifiability, and your security, none of which can be achieved without a unifying architectural vision. So basically, your architecture is an artifact for the early analysis to make sure that a design approach will lead a system that is acceptable. Right. So this is a definition from a very popular book, which is Bas Clements and Casman, and we will be using some of the topics from this particular book as well. So your software architecture of a program or a computing system is the structure or the structures of the system which comprises your software elements, the externally visible properties of those elements, and the relationships among them. So I took this definition from Baskelmans and Kasman, your second edition. It's a very popular book as far as your software architecture is concerned. Now, basically, your architecture, when we say architecture of a system, so basically it describes the major components, right? So that means I'm dealing with the components. I am dealing with the relationships among these components and how these things are going to interact with each other. So your software architecture and design includes several contributory factors, which can be your, business strategies. Sorry, it can be your business strategies or the business logics. Uh, it can have a quality attribute. It will have human dynamics. It will have design. It will also have the IT environment in which my to be developed application is going to run. Right. So your architecture, and from these things, you might have got the idea that the architecture is what is visible externally. Right. We are not talking about the internals. We are not going into your coding logics. Right. I am only dealing with your external visible components, how my application is going to look like. And it talks about the implementation details of a component. And if suppose I'm dealing with implementation details of the component, then basically we are not talking about the architecture. We are talking about the development details about it. The development details about the application. And this is not something which is not the architecture. Right, this thing is not your software architecture. Your quality attributes can be your design, your business strategies, the IT environment, the human dynamics. These things can be a part of it. So this is the definition from your Basque events and Casman, right? We have once again introduced it, right? We have previously talked about this, just to give you an idea about after all these discussions, that now the picture becomes clear. My software architecture of the system is the set of the structures needed to reason about the system, about the structures. Sorry, there is a repetition, which comprises your software elements, some of the relations among them, and the properties of both. Right. So majorly we are talking about components and the relationships. Right. There can be multiple relationships. We'll see in some of the classes where we'll deal with the components and the associated relationship. Yeah, so this is the definition of software architecture I took from ISO IEC 42010, which talks about software quality. So here, fundamental concepts are the properties of a system in its environment, embodied in its elements, and relationships and the principles of the design and the evaluation. Right. So these things become the part of your software architecture. Basically, your software architecture gives you an abstraction to manage the system complexity and to establish a communication and coordination mechanism among the components. So now, what basically is a software architecture? So these points will answer to these things. Your architecture defines the structure. Your architecture defines the behavior. Your architecture focuses on the significant elements, and your architecture balances the stakeholders' need. Your architecture embodies the decisions based on some of the rationales why we are going for, let's say, two-tier architecture or cloud-based environment or three-tier architecture. So, because everything will have a rationale, right? An architecture may conform to an architectural style as well. This architecture is influenced by its environment as well. And this architecture influences your team structure as well. Because let's say if I have a standalone application, right? So the architecture will be totally different. If I have a distributed system, my team will be different and the architecture will be different for a distributed system. And obviously the architecture is present in every system. Your architecture also has a particular scope as well, right? Your architecture also, you'll see in the later stage that this is something which is reusable as well. Your architecture becomes reusable. Design components becomes reusable. Yeah. So this is
So,
the, yeah,
so
Rahul.
what is environment in the previous slide?
Yeah.
So it
So
comprises of teams or
yeah, no. The architecture is influenced by its environment. That means, let's say, in what kind of environment I am going to run my application. Environment means I can have a simple desktop-based application. Anna,
yes, sir.
standalone. Right. I can have a cloud-based application. So the environment is a cloud environment. So my architecture will be this time a different one,
Okay,
right?
sir.
Because the architecture for a desktop-based application will be simpler one, but for cloud-based it would be different one, right?
Yes, sir.
Yeah. So that's a major difference. Yeah. So folks, I realize I am not able to give full energy still. I I'll take a break here, and I think I'll meet with you with full energy from the next class. Probably I need some little more break because it is becoming tough for me. I hope it's okay with everyone.
Yes, sir.
Yes,
Yeah,
sir.
yeah. Then yeah, sure. Thanks, Hardik, Tanisha. Uh, so we'll be then meeting, uh, thoroughly with a lot amount of energy from the next class. Then, yeah. Thank you, Abhinav. Yeah. See you then. See you. Bye bye.